Hey everybody, let's spend a little bit of time today talking about coordinate covalent bonds. This is part of that section that is talking about other types of bonds that we have to know about. And so there are ionic and covalent bonds, but then there are these things called coordinate covalent bonds that this video is going to address. So let me get rid of this guy, and then let's move forward. Let's see. So let's first describe what coordinate covalent bonds are. So it's an unequal sharing of bonding electrons. So the example that I kind of come up with is like in carbon monoxide. Okay. Now this is covalently bonded. We know that. Okay. And so carbon has 4 electrons. Okay. And so it's 1, 2, 3, 4. And oxygen has 6. 1, 2, 3, 4, 5, 6. And what we know is that this thing bonds. We can use our Lewis dot structures, and we make a bond there. But we notice that this guy doesn't have an octet. And so now then we go in here and we make this, and this guy doesn't have an octet, so we make another one. And so when we do that, we look and carbon has 6 and oxygen has its 8 bonds. So what we have is this kind of, okay, that. But carbon isn't happy. So what ends up happening is these 2 extra electrons come in here, and they're both from the oxygen. So we end up having this as our structure, which is the correct Lewis structure, but it happens to be a coordinate covalent bond here. So that becomes really interesting when we when this happens in chemistry. It's still just a covalent bond, but when it's this unequal sharing, we call it coordinate covalent. Now, if there is a coordinate covalent bond, we sometimes symbolize this with an arrow. Now, in this case, I know it's a bad example, we didn't, because it's a triple bond, okay? And so I guess, I've never seen it drawn like this, but I guess we would do 1, 2, 3, this, and with the arrow going towards, I guess I wrote my arrow backwards. Man, I'm really a mess here. Okay, and then the arrow goes towards where the electrons are moving to, so it would go this way because the electrons started on oxygen and moved there. Yeah, so but I've never seen carbon monoxide drawn that way. Okay, but if you have something else with a single bond, okay, then you'll see that the single bond is represented by an arrow that is going from where the electrons were to where they're being shared to. Okay, so let's go to the next slide here. Okay, and so this is our example problem. It says determine the best Lewis structure for NH3BH3. Okay, well this is a very classic example of a coordinate covalent bond, because we know that boron, let's go back here. Let's go to boron. We know that boron, what do we know about boron? Boron is special because it typically just wants to have 3 bonds, because there's only 3 electrons around it. It's small, and so boron, and then the boron trihydride looks like this. Okay, and then ammonia, NH3, looks like this, but it has these 2 electrons. So ammonia and BH3 are allowed to bond, or can bond, and they do so with a coordinate covalent bond. And so it's kind of neat. So it's all these, remember that those rules for drawing Lewis structures, well, they still kind of hold true here. And so what's going to end up happening, and I'll draw it in red here, is that this guy is going to have a coordinate covalent bond that looks like that. And so that's your sample problem. Okay, so it's not much different than what we have been dealing with coordinate bonds, covalent bonds, the coordinate just means that when you're drawing that Lewis structure, we have to make sure that we see where the electrons are coming from. So that's pretty cool, and I think that's the end of this video. Yep. Have a great day.